Hello everybody, welcome back. As you can see, I am in a different location right now. You can see this messy bookcase behind me indicating I am back in my office in Macomb. I'm actually at Western Illinois University for a couple days. So last time we talked about hypothesis testing for the mean where sigma is known. Now we're going to talk about what to do when sigma is not known. And we're going to see that not a whole lot changes. There are basically only two things that change. One is that we use the sample standard deviation instead of sigma. And the other thing is that we have to use the t-distribution instead of a normal distribution, which we already sort of know how to do using confidence. We did that with confidence intervals. Everything else pretty much stays the same. So here are the guidelines when we're trying to find the population mean using hypothesis testing. We first, in this case, will verify that sigma is unknown. Then we check that the sample size is random, or rather the sample is random, and either the population is normally distributed or the sample size is at least 30. Then, after that's out of the way, we state the null hypothesis and the alternative hypothesis and identify which one is the claim. Remember, the claim, if the claim has some sort of equality in it, then it's going to be the null hypothesis. Otherwise, it's the alternative hypothesis. Next, we specify the level of significance, alpha. That's going to be given to us. We identify the degrees of freedom, which is always one less than the sample size. Then we determine the critical values, or values from the t-distribution. Well, we first need to find out, are we using a right tail test, a left tail test, or a two-tail test? It depends on what the alternative hypothesis says. So we'll go on with that. But once we do, then we use the t-distribution. We identify the degrees of freedom and look up, use the t-distribution. Then that gives us the critical values. That gives us our rejection region. And then once we do that, we compute the standardized test statistic. And it's almost the same formula as before, except we're using S, the sample standard deviation, instead of sigma. And you just want to keep that in mind, because if you're actually given the data and you do that on your calculator, you want to make sure you're using S and not sigma. Okay? Because of course those are two different numbers. And then you either reject or don't reject the null hypothesis, and then I interpret your decision in the context of the original claim. So let's look at the first couple of examples, which I already did ahead of time. In this case, the claim said that mu is equal to 15, and we want to test that at a level of significance of 0.01. So the sample statistics is given. So you take the sample of size 36, and you get a mean of 13.9 and a sample standard deviation of 3.23. Because n is bigger than 30, we know we can go ahead and proceed. The degrees of freedom will be 35. The claim, it has equality in it, so it must be the null hypothesis, and then the alternative hypothesis must be mu is the opposite of that. Is not equal to 15. Because if the null hypothesis is true, the extreme values could occur both bigger or smaller than 15. So that's why we use a two-tail test. And in this case, we use to find the critical value, we use the table and see if we can. I can show you here on the. Here you can see that there is a there's a special level here for one tail or two tails, so you use two tails, and the alpha is 0.01, and then you go down to the right degree of freedom. So that's how we get 2.724. All right. Then we have, then t is computed this way. We plug everything in. We get minus negative 2.04. That is not in the rejection region. So we don't reject the null hypothesis. And because we're not rejecting the null hypothesis, and the null hypothesis is the claim, we don't reject the claim. So we would say there's not enough evidence to reject the claim. It's not the same as saying that we support the claim, which we just say we can't reject it. Okay, next example. The claim is mu is greater than 25, and our level of significance is 0.05. We want to, in this case, we want to, because the claim is strict inequality, that's why it has to be the alternative hypothesis, and the null hypothesis is the opposite of that. Mu is less than or equal to 25. Okay, so our degrees of freedom is 1 less than 17, that's 16. It's a one-tailed test because the extreme values are going to be bigger than 25. So they're over here, it's just one tail. It's a right tail test. And so we look under a one tail, degrees of freedom is 16, alpha is 0.05, and that's how we get this 1.746 from the t-distribution. We compute our sample standard statistic, plugging everything in, and we get 2.13. That is certainly bigger than this number, so it's in the rejection region. So we reject the null hypothesis. And because we're rejecting the null hypothesis, we can support the alternative hypothesis, which is our claim. So there's enough evidence to support the claim. Okay. All right. Go ahead and try the next two examples on your own, and we'll do this. We'll see how you did on the next video. Thanks.